everybody. This video is dedicated to my beloved free grade AB from the high school where I teach, and the motivation comes and is kind of especially dedicated to my student Shimon, who was during today's lesson really curious how we can simplify or modify or make any linear to linear rational function so that we can very easily draw the chart of the function by using transformations of the graph. As you can see on my screen, there are basically 4 cases which I want to go through, and each case is getting harder and harder, and this one is really like the most advanced example how to rearrange this fraction so that we can easily draw the chart by using the parent function 1 over x, or let's say y equals 1 over x, and then use a couple of transformations to find the final chart. So let's start with the easiest function given by the relation y equals x minus 2 divided by x plus 1. Let me just move this a little bit higher because we don't need anymore the title. Now let's start with the first function. As you can see, what is the main difference between these 4 functions or relations, functions given by these definitions, is that here in front of x we have number 1 times x, number 1 times x, and then there comes the easy way when here is number 2 and here is number 1. Then it comes a little bit more harder because here is number 1 and here is number 2, and really the most advanced linear to linear rational function can be given by 3 times x, and in the denominator we have 4 times x. So during our today's lesson we started mainly with really this simple solution or function, and we have said that we want to have this function and rearrange it to something like a over bx plus c plus some kind of d, where, as we already know, this gives us the information about the transformation of the function c, which is shifted to the right or to the left depending on the value of c, and then it's shifted up or down depending on the value d. So how can we find such a description or definition of the first function? This one is really quite simple because, as I said, we are looking for some kind of multiple of the denominator, and we want to find it up there because we want to cancel some numerator and denominator. So we are looking for x plus 1 being there, and as we have 1 here and 1 here, it's really simple because now what we want is to find any value which can be added or subtracted from the numerator so that it will give us x take away 2. So what is the number? So that x plus 1 plus any kind of number, let's say e, so that it will be equal to x take away 2. And as you can see from this equation, it's simple because x's we will get rid of them, and then we will remain with the equation 1 plus e equals negative 2, which would mean that e must be, if we apply the subtraction of -1 from both the sides of this equation, we will get e must be -3. So we have to modify the numerator from our expression x plus 1 to take away 3, and then it would really lead us to the fraction x -2 divided by x plus 1. This was just the proof that this is really the same thing, but what is most important for us here is that we can see that we can split this fraction into like two fractions, and the first fraction would be x plus 1 divided by x plus 1, take away 3 divided by x plus 1. Because as you already know from the fractions, as we have the common denominator in both, we can really simplify, or we can do the subtraction of these two fractions, and we will get this kind of fraction, which will definitely lead us to this fraction. So we are now okay with that, so we can simplify the first fraction, and it would come to number 1 take away 3 over x plus 1. So we can really rewrite our function f defined as x take away 2 over x plus 1, that this is the same function as 1 take away 3 divided by x plus 1. And as far as we have this form of our function, we know how to construct the graph of this function, because we know that the parent function of this function is 1 over x, which graph goes this way. Okay, what we can read from this relation or definition is that our function is moved 1 unit to the left, which means that there will be vertical asymptote going or passing through -1, and I will draw it like here, which is -1, and it would mean that this is our new function, and our new function basically is 1 over x plus 1. This plus 1 means shift to the left by 1 unit. Okay, now what is very important is to keep in mind that we do multiply it by -1, or we can simply say we do multiply our function 1 over x plus 1 times -3, which will lead us to the function -3 over x plus 1. What this means, basically, if we write this in general, we have our red function, which is f of x, but please keep in mind that the argument is not x but x plus 1, and we do multiply this function by -3. What it means? It means that both these hyperbolas will flip, and all the numbers will get like 3 times higher value for y coordinate. So let me draw this in like new chart or new xy plane, and this multiplication by -3 doesn't impact any of my asymptote. So my asymptote passing through -1 will remain on the same place. The only thing, or basically two things, will change. And the first thing is because we are multiplying by negative number, so all y values will become negative, and the slope, or I don't know how to say that, sklon tej krivky, will be different than the red one, so it will rise quicker and lower quicker. But what is important and we really don't care about now is how fast will it increase or decrease. how many times, but basically 3 times faster. It will be increasing and decreasing here. So this is our chart of the function given by the definition -3 over x plus 1. Okay, and what we want to do with this function, basically we can change this definition or description. We add number 1. Okay, adding number 1 would mean that all the values of our function being drawn in blue will have each value of the y-axis plus 1, but basically the most important thing is that this addition of number 1 would mean that our horizontal asymptote, which is now identical with x-axis, will move 1 unit up. So it means if we want to draw this function from this blue function, we need to move our horizontal asymptote 1 unit up. I will use green color for showing that. So it means this is our asymptote moved to 1, and please note that this addition doesn't have anything to do with our asymptote, vertical asymptote, which remains on the same place and will pass through -1. So these are my new asymptote, and I can finally draw the chart of the function 1 take away 3 divided by x plus 1. So this is my function, the graph of my function. What is interesting about this function maybe is if we want to calculate the y-intercept, which would mean that x equals 0. So basically my intercept with the y-axis is x equals 0, and I have to calculate the y coordinate, which would lead then to the equation 1 take away 3 over 1, which means 1 take away 3, which is -2. So I can really clarify, and I can say that my graph or my chart will really pass through the point with the coordinates 0, -2. So intercept with y-axis has the coordinates 0, -2. And good question, and what I just thought about is that my chart is really not drawn properly, because this part of the hyperbola must pass through also through the x-axis. So maybe it makes sense to find the coordinates of the intercept with the x-axis, which you can do, and I'm not gonna show this in this video because this is not like very important, and this is not the scope of the video. You can find for which x the value of this function is equal to 0, and if you find, you can really identify this point. What I suggest when you do train yourself finding out the graph of the linear to linear rational function, you use, as I always suggest you, very super special program called Desmos, and there you can find that the graph or the chart we really drawn right now is equal to this function and this function. Let me do it, but I'm not sure if you will see what I'm doing, because recording my screen makes kind of problems with this. So let me just do it for you. If you can see it, I'm happy, but I think it's not gonna happen. So my function is x take away 2 in the numerator, x take away 2 in the numerator, and x plus 1 in denominator. Okay, the chart is like this. Let me do the print screen of the function and the evidence. So this is it. I'll now share it just like really quickly. So as you can see, this is our function we were talking about, and this is the chart. Okay, and as I said, I really was right. The passing point through is 0, -2, and if you would calculate the second intercept, you will find that the second intercept coordinates are 2 and 0. What you cannot see here are the asymptotes, but I'm pretty sure you can see that in this chart the first or vertical asymptote is passing through x being equal -1, and the second or the horizontal asymptote will go through the line, or will never intercept the line being defined by y equals 1. Okay, so this was our first function, which you could really understand during my lesson, and I hope you did. Okay, the second example is about this function given by this relation or definition. So what is the issue here now is that we really have something like 1 times x, and if you really think about it, you can very easily find out what we can do here, and the solution would be our function is 2 times x plus 3 over x plus 1, and what we are looking for is, again, in the denominator we have x plus 1, and we are looking for the expression x plus 1, and we want to modify this expression so that we will get in the numerator 2x plus 3. What is the easiest way? How to find out? Okay, so the easiest way is that we really write something like this: 2 times x plus 1, but now something is missing again here, plus any number of e, so that we will get the numerator like 2x plus 3. So let's find out what the number e is. If we will find our number e, we are really happy and we are done here. So it means 2x plus 2 plus e must be equal to 2x plus 3. And again, the same procedure applies here as before. We will get rid of this 2x term, and what will remain is 2 plus e must be equal to 3, which means if we take away 2 from both sides, e must be equal to 1. So our function e is 1, just let me remember this. So our function can be rewritten, or let's say simplify, like 2 times x plus 1 plus 1 over x plus 1. And the same procedure applies here. We can split these like into two fractions, which will lead us to the first fraction in this form, plus 1 divided by x plus 1. And if we simplify this fraction, we will get our function being defined like 2 plus 1 over x plus 1. And again, this one is simple. We use to draw the chart of this function with our simplification or some kind of tricky things. This is our parent function 1 over x, and as we can see from this is first transformation, which will move our vertical asymptote to asymptote which will pass through -1, and we can draw the function 1 over x plus 1, which will be something like that. Okay, what do we apply like in the next step? We just move our horizontal asymptote 2 points up, because all the values of our function, and let me draw the chart again, but in like new one, this is our x and y coordinates. This transformation has nothing to do with this asymptote. So basically our vertical asymptote will stay on the same place, so it will pass through -1, and our horizontal asymptote will be moved to a line which can be defined like y equals 2. Okay, and basically, okay, I was supposed to use new color but I didn't, so this is my chart. Okay, and again, as you can see, here are two intercepts with y-axis and x-axis, and you can find the values for these intercepts again by using the fact that this intercept has the coordinate 0 for x, and this intercept has the coordinate 0 for y-intercept. If you find, you can draw the chart or graph of this function like really properly. And again, I advise you, what I advise you for a long time, to check if your simplification or steps you applied would lead you to the same graph of this function, like the function given. By a couple of simplifications you came to this function, if it is really still the same function. So let me do it for you. So the function is defined like y equals to x plus 3 2x plus 3 over, or divided by, x plus 1. And this time I will also try to draw the asymptote. So the first asymptote has the equation y equals 2. Okay, nice. And the second asymptote has the equation x equals 1. -1. Okay, so this is what you can see when you use Desmos. And let me share my result with you so that we really can confirm that everything what we did was correct. So here is the result from the Desmos. As you can see, this is my original function, this is my horizontal asymptote, and this is my vertical asymptote. And please note and see the red lines on the graph. Okay, now I will show you the proof that this is really the same function as we did or simplified here. So let me just do it again in the Desmos. So my function is 2 plus 1 over x plus 1, x plus 1, and now in this chart or proof you will see the same function as before, but in this case the chart or graph of the function will be in purple, but as you can see it's still the same thing. So this is how you can check your work. You start with the red one, like the function which was given, then you put into the Desmos the function you found out that must be the same as the given function, and if these two charts overlay or graphs overlay, then you are correct. Okay, thanks for watching. As this video has already 24 minutes and I want to upload more sophisticated solutions, I will split these videos into like two parts, and in the second part I will come with the explanation how you can transform this function, which is a little bit harder than this one, because as you can see number 2 is in the numerator, but here number 2, or it doesn't matter, any kind of number which is higher number than in the numerator is a little bit complicated, more complicated, but still possible to solve. Okay, thanks for watching and see you in a couple of minutes during my next video about more complicated or more challenging tasks for the two remaining linear to linear rational functions. Thanks for watching.